So I was saying, in one cycle of the current, the rod undergoes 2 elongations in compression. So the frequency of ultrasound is going to be 2x the frequency of your current. Now that is not a problem technically, it's perfectly fine, it's a good thing. But when you're dealing with mathematical computations and all that, sometimes you're given the frequency of AC current instead of the frequency of ultrasound, and then you're asked to find out something related to the ultrasound. So what happens there is, people might confuse this frequency for that frequency, and then they end up making miscalculations. So it is best if you can have a one-to-one relationship between both the frequencies. If this frequency is that equal to that frequency. So that is just so that people do not make errors in calculation. It is not scientifically necessary that both have to be equal. If you can remember that this equals twice of that, it's very well perfect, you can go on and do it. But just so that people don't make a mistake, we have this idea. What we do is, we initially apply a small DC current. DC is a current coming from a battery. So when you apply that, again a current and a magnetic material, a field is created, so there is some elongation which we call delta L DC. Now after this, now to this rod which has already been elongated because of DC and has not come back to its original position yet, to this we apply one full cycle of AC current. Now it undergoes 2 elongations, 2 compressions. At the end of one cycle of AC, it is coming back to L plus delta DC and not to its original length L. And once it has come back, now we switch off the DC current, it comes back to L. So irrespective of how many elongations and compressions it went through, ultimately after one cycle of AC has completed, my rod only went through one full cycle of full elongation and compression, meaning even though it went from delta DC to something more and came back, at the end of my AC current full cycle, it was still at delta DC, L plus delta DC. So only when I switched off the DC, it came back to delta L. So now you can say one full cycle of AC current, only one full cycle of elongation and compression happened. I say full cycle because it is considered to have completed its cycle only when it comes back to L. So now you have a one-on-one correspondence. So your calculations get simplified. So does this make sense, or was it too fast, too technical? You want me to repeat something?